So here's the type of problem that we were facing in the last lesson. It's just a basic find the equation of the tangent line. Okay, so we're finding the equation of the tangent to the function y equals tangent of x at the point where x equals pi over 4. Alright, now if you remember, your tangent graph has asymptotes at negative pi over 2 and pi over 2. It goes through the origin and it looks something like this. Okay, and of course it's periodic like all the trig functions are, so this repeats infinitely both directions. Okay, so what?
At every pi over, like.
Yeah, if you count up another pi, because the period is pi, so at 3 pi over 2, at 5 pi over 2, at 7 pi over 2, there are asymptotes. And this thing here repeats. It kind of looks like a cubic, except it approaches an asymptote instead of continuing to go off forever. So what we want is, there's a point here at pi over 4, okay? And what is the point? What's the, because we want the equation of this line right here. So the first thing we need to do, remember, is find the point that we want to hit. Okay? So the point is pi over 4. And then what is tangent of pi over 4, guys?
Negative
4 pi? No, sorry, I was thinking differently.
Oh, the
Use the unit circle.
Use the unit circle.
So it's
What's sine of pi over 4?
sine of pi over 4 is 1.
You guys with us
It's
here?
radical 2 over
I'm
2.
trying to import this.
So it's radical 2 over 2 over radical 2 over 2. This
Yes.
would be
1. Okay? Tangent of pi over 4 is 1.
Wait, can we go over
Okay.
that? Yeah. Can we?
We'll review some of the unit circle when we get to exam review, but you guys need to know your unit circle. So if you're
Not so much that I don't know
I
the
can't
unit
do my
circle, just I don't understand like what Matthew is doing to get to that one.
Well,
I know the unit circle.
the unit circle gives us all the cosines and sines, the x and y
But
coordinates.
why is it the sine of pi over 4?
It's not the sine, it's tangent. Tangent is sine divided by the cosine.
Oh, okay.
Okay, so remember, sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is also root 2 over 2.
Right.
So when you divide it by itself, it equals 1. Okay?
Yeah.
So we need to make sure that we know our unit circle really, really well. Alright, so that's one part of this. We need the point, we also need the slope. Okay? So how do we find the slope? The derivative, okay? So we need the slope of the tangent line. So what is the derivative of tangent? What?
Negative secant squared?
Close, just secant squared.
Okay.
Remember, it's only negative if it starts with c.
Okay.
So cosine, cosecant, and cotangent, the derivatives are negative. The other three, the derivative is positive. Okay? So, this is secant squared. Okay? And if we're doing secant squared at the point where x is pi over 4, that's 1 over cosine squared of pi over 4. We already said that the cosine of pi over 4 is
radical 2 over 2.
root 2 over 2. Okay? So, I have now a 1 over root 2 over 2 squared. Okay? What's root 2 over 2 squared?
2 over 1 half.
Yeah, 2 over 4, or 1 half. So when I flip that, because it's 1 over that, I end up with 2. So the slope of my tangent line here is 2.
But then we don't have to make the equation.
And now it's the algebra 1 part of this. Just find the equation of the line. Alright, so our y minus y1 equals the slope times x minus x1. Okay, if we want it in slope-intercept form, we'd solve it for y, so we'd have 2x minus pi over 2 plus 1. Okay, that would be our equation of the tangent line. Either form here. Okay? So that's what we did yesterday. Yesterday we didn't do any examples where we actually had to use trig, but that's the same thing that we were doing yesterday. We were looking at how to find the equation of the tangent line. But we want to go a little bit further than that. Okay? Because there are other things that we can use this same principle for to do other stuff. Okay? For example, a number of times when you have a tangent line, we say that a tangent is where the line hits the graph at only one point, okay? Or it's the line that hits the graph only at one point. But in those cases, we're talking about in that general vicinity, okay? Because obviously, if a graph curves back on itself like this, I could have a line that is tangent here, okay, that's tangent, but then later on, because it curved back on itself, we intersect the line again over here, okay? Well, we can actually find that point, okay, and that's what this application here is. Find the coordinates of the point, or points, where the tangent to y equals x cubed plus x plus 2 at the point 1, 4 meets the curve again. Okay? Now, if I want to find where a line meets a curve, what do I have to do with it? Or how do I do that? Okay, if it's y equals and y equals, I set it equal to each other. I solve the system of equations, right? So, in order to do that, though, we need the equation of the line. Alright? So, stage 1 of this problem here is find the equation of the tangent line. Alright? So take a minute or two here, and go ahead and find the equation of the tangent line to that curve at the point 1, 4. Alright, so a lot of you are making good progress with this, alright? So, your dy dx, or your y prime, is 3x squared plus 1. So that means the slope of the tangent line is going to be this when x is 1. So 3 times 1 squared plus 1. Okay, remember the derivative at a point gives us the slope of the tangent line. So here our slope equals 4. And now we can find the equation of the line. Remember point slope form, so y minus the y coordinate 4 equals the slope, which was 4, times x minus the x coordinate 1. Okay? Now, for this, we would want to go ahead and simplify. So we have y minus 4 equals 4x minus 4, so y equals 4x. And the reason for that is because of our ultimate goal. If we want to see where it meets the curve again, we have to find the intersection between the line and the curve. Okay? Now, to do that, we're going to, since they both equal y, we can set the other sides of the equations equal to each other. So we have x cubed plus x plus 2 equals 4x. So we get it equal to 0, and we have x cubed minus 3x plus 2 equals 0. Now I'm going to tell you, we all know one of the answers to this equation already. We do. What? How do we know 1 is an answer to this equation?
Because that's the point that it, that's 1, 4 is the point where it first meets the
Yeah. That's the point of tangency.
Yeah.
So we know that it meets, we know it meets that curve at the point 1, 4. So in other words, and that's the thing, with this equation, it's a cubic. There's not a great way of solving this, or a real obvious way of solving this, but I do know that I could factor out an x minus 1. And the key to getting the other answers, the other 2 answers in this equation, are to figure out what would be left over. Now, this is where you could think of this in terms of the rational zero test. Remember with the P's and Q's from pre-calc honors?
Yeah.
All right? Or just think about, in order to factor out, when you're factoring, you're dividing it out, right? So if I need to divide out an x minus 1, the nice thing is I can use synthetic division. Okay, if I'm dividing by an x minus 1, I'll put a 1 in the box, and then I put the coefficients. There's a 1x cubed, there's a 0x squared, a 1x, and a 2. Okay, so we have our synthetic division. Oh wait, sorry, I read the wrong line. Not a 1, it would be negative 3.
And 2.
There we go. Okay, so 1, 0x squared.
Dividing x minus 1 out of the equation because we know x minus 1 is already going to be a factor. Sorry, spitting still.
Yeah, we already know 1 is going to be an answer because we know this point's on there.
You already know it's going to be an answer. So let's do it again.
So, remember for synthetic division, you add down 1 plus 0 is 1, then you multiply over by this 1 in the box. So 1 times 1 is 1. We add down, multiply over, we add down, multiply over, add down, and it better end up being 0, otherwise it's not a factor. Okay? But the reason why this is useful is because while this was an x cubed, we just divided by a power of x, so what's directly below it is now an x squared. And then this is x, and then we have a constant, and then that 0 is the remainder. Okay? And we want the remainder to be 0 because it's an actual factor. So now I know that what goes in the parentheses here is an x squared plus x minus 2, which is only a quadratic, and you can solve that now. Okay, you can solve the quadratic either by the quadratic formula, or, better in this case, by factoring. Okay, because this is an easy one to factor. So it's x plus 2, x minus 1. Okay, notice the 1, the point of tangency, was a double root. That usually happens.
Yeah,
Okay?
at the point of tangency.
At the point of tangency, it ends up being a double root of this equation. 1 is an answer twice. But the other answer here, x is 1, we already knew that. The other answer is negative 2. Okay? Well, it asks for the point, right? So we only have an x coordinate. So the point should be negative 2 something. And just to double check your answer, you can plug it into the line and into the original function, and we should get the same y coordinate, right? So negative 2 times 4 is negative 8. If I do negative 2 up here, I get a negative 8 minus 2 plus 2 is negative 8. Okay? So there's the point where this will hit the curve again. Okay? Does that make sense? Okay? if you want to see what this looks like, the point, well, the original equation is going through 0, 2, 1, 4. We also know it goes through the point negative 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay. But we also know that the tangent line is going through these, okay? So the original function, let's see, it's positive. So I know it's, okay, so it's got to be doing, not sure what exactly that would look like. Hang on.
Same process.
All right, so this one actually, it ends up looking something like this. That's what the original function looks something like. And then you can see the tangent line there. It has its point of tangency, but then hits it again down at negative 2, negative 8.
But it's not also tangent
Okay.
there.
It's not also tangent there, it's just that's another intersection.
Oh.
Now think about this, when we talk about tangents, okay, the tangent line is the path we would take. Let's say we were traveling along this curve in this direction, okay? And for whatever reason we lost control right here at this point, okay? This is like if you're swinging something around over your head. The moment you let it go, whatever the tangent line to the path it was traveling at the moment you let it go is going, that's the direction. All right, so if you want to see a tangent line in real life, spin something around your head and then let it go, and you follow that path, that'll show you the tangent line to the circle that was going around your head. Okay? Well, here, if we lost control, right at this moment, it would start going at this direction. And if nothing else impacted it, it would continue going to this direction. So, if the path is going like this, where will we be able to find the path again? Right down here. Okay? So, if we know it lost control here, it goes on in this direction. Or let's say we lost control and we went in this direction. If we keep going, we'll be able to find the path again right down here. Okay? So, kind of interesting look at it. Now, another thing that we can do is, what if we don't know the point that's on the curve? Okay? We know a point that we want the tangent to hit, but we don't know a point that's on the curve. Alright, so you'll notice here in this case, we started this one with a very basic curve, the y equals x squared. Okay? And that y equals x squared, we want to find what the equation of the tangent would be that hits the point 2, 3. Okay? Now here again, we're going to have to use systems of equations, but in a little bit of a different way. Okay? We're going to find the equation of the line, or actually, we don't even need the equation of the line per se. We are going to use the slope of the line in two different ways. Okay? So you can see the line right there going through the point 2, 3. And why is that point labeled a squared? I don't know what it is. Why is it a squared? And not like a 3a plus 5, or
Because it's on a parabola.
it's on a parabola. What's the equation of that parabola?
Square.
X squared. So if we're looking for some random point where x is a, then y has to be a squared. Okay? So you're using the function here to come up with the coordinates of your unknown point. Alright? So, what's one way of getting the slope of the tangent line? Okay, the derivative. So, y prime equals what? 2x. So, when x is a, what's the slope of our tangent line? 2a. Okay? So here we're finding the slope with y prime. Okay? Oh wait, sorry, no, I said a and I wrote x. Okay? Now, how else can we find the slope?
The points,
What do you mean with the points?
like 3, like y 2 minus y.
Yeah, our slope formula, okay? So we have the slope with the formula. So yeah, y2 minus y1. So the slope of that tangent line is going to be a squared minus the 3 over a minus the 2. Or you could have both of those reversed as long as you're consistent. 3 minus a squared over 2 minus a. Okay, now I know that I want those slopes to be equal. So we need to make them equal to each other. Alright, here, red and blue make purple. So we'll do 2a equals a squared minus 3 over a minus 2, and now we're back to our Algebra 1 skills. Solving an equation. Okay? Does everyone see how we got that equation, though? We found the slope two different ways.
Wait, why did you do a squared times 3 over a minus?
Because we have 2 points that are on the line. Here.
Oh, so you just
And
did
here.
Y, you just did y over 2 minus y 1 or whatever.
Yeah. Yeah. Okay? So let's go ahead and solve this real quick just to finish it off. I'm going to multiply both sides by an a minus 2. So that's gone. And we've got an a squared minus 3 over 2a squared minus 4a. I set it equal to 0, so I have an a squared minus 4a plus 3. And please don't use quadratic formula, because this is easy to factor. We get a minus 1, and we get a minus 3. And what do you realize here? There's actually 2 different times when this would happen. A could equal 1, or A could equal 3.
Well, that's because it's a parabola, so it's the same on the other side.
Well, it's actually where it's the same. Check this out. If I kept drawing this, notice what the 2 points are. We have the point 1, and then 1 squared is 1, so there's 1, 1.
Same.
But we also have the point 3, 9. Just because they only drew that side, there's also another tangent up here. So there's 2 different places, 2 different lines that are tangent to the curve and go through the point 2, 3. Okay?
Why isn't that point on the graph?
What do you mean?
The
mess with
2,
you.
3. I
Well,
thought-
because that was the whole point of this. If we want to hit 2, 3,
Oh, it has nothing to. No,
it's
but-
not on the graph. But we want our tangent line to pass through that point. That was the whole point of
Oh,
this.
never mind. I was
Yeah.
thinking about the last one where it had to hit the curve again.
Oh, no, no, no. Yeah,
I-
2, 3 is not on the curve. It's just any random point. And that's the thing. You could pick any point, almost any point, and you could find a tangent line that would hit it. Okay? Now, with this parabola, you'd have to pick a point that was outside the parabola. Okay? Because this one, if it curved back on itself like a cubic, then you could pick any point you wanted on the graph.
You could do
So,
normals, though.
Huh?
We did the normal, you could pick anything.
You could, yeah. If you picked a point inside the parabola, you could find a normal that would hit that point. Yeah.
Okay, so now we have to write the equation.
Okay. Well, no. The whole point of this. Oh wait, no. Yeah, we do want the equations of the tangents. All right. So when a equals 1, the slope y prime is going to be 2 times 1, which is 2. So we have y minus, not equals, y minus 1 equals 2 times x minus 1. So y equals 2x minus 1. If I get that in the slope-intercept form. However, if a equals 3, we have the point 39. The slope of the tangent is 2 times 3, which is 6. So I have y minus 9 equals 6 times x minus 3. Y is 6x, negative 18 plus 9 is a negative 9. Okay? So those are the equations of the two tangent lines that hit the point 2, 3 and are tangent to the curve y equals x squared. Okay? So do be aware and be careful when you draw pictures. Don't assume that there's always only one answer. There may be more than one. Okay? On the last one, when we were looking for where does it hit the curve again, that one was just a cubic, but it's possible that, we had something like this, and you could have a tangent line that hits the curve, in this case, like 3 times. So you might have 3 different answers.
When
Okay.
you were getting for like y a equals 1, a equals 3, where did you get the y-intercept? Would you plug it into the 12?
Wait, when a is 3, how'd I get the y-intercept?
Yeah, like
I just used point slope form, and I solved it.